Hello everyone, welcome back to the series of Google KickStart. Okay, let me make little bit setting here. Okay, before I start, you people can enjoy this Google cocktail. I believe that okay, if you will drink this cocktail, then you will definitely crack the Google Kickstart rounds, and if you will score good in that, definitely you will get the chance to go for the interview of the Google. Please take it and tell me okay, I have taken yes and no. Anybody who is taking, please write yes. Please write yes in the live chat, and if anybody is not interested, please write no. And this is my belief, this is my strong belief that if you will drink this, that is this much easy. If you will drink this just by assuming okay, I have drink it, write yes. If you drink it, okay, just imagination, and if you drink it, I believe that you will definitely crack the Google Kickstart. Okay, you may be thinking sir going to be mad, but this is my belief. Please write in the live chat if you have drink it. I'm checking the live chat, please. And this will confirm me also okay, I'm audible or not. Okay, please, anybody please write okay, you have taken it, you have drank it. Anybody? Okay. Anybody, please taste it so that we can proceed. If you will not drink it, then I don't think this will be possible for us to move on. This will confirm me also okay, I'm audible to you people or not. Anybody please? Okay, let me confirm I'm audible or not, and if you have taken this or not. Anybody? Okay, whoever is taken it, whoever is drink it, let me tell you actually what are the ingredients of this cocktail is actually. One is programming language, that is C++ or Java. You need to be know if you have drink it, okay, and you have drink the DSA also. This flavor, this is the DSA, and you have drink CP also, competitive programming, and finally you are working with Google Kickstart. You are solving the previous Google Kickstart rounds, and if you are doing all that stuff, I believe this will be easy for you people to get a chance to appear for Google and to get work with the Google. Okay, so these are the basic ingredients of this for Google Kickstart also. Okay, if you want to go for Google Kickstart, otherwise I will start from the very basic. I will cover the concepts from the point of the beginner, but the expert people will also able to understand. Okay, they will also be able to get something from the session. Okay, by the way, my name is Puneet Kansal, and in this session I will discuss about, okay, I will cover question 1. Let me use the pen. I will cover only question 1 in this session of round F. Okay, and we will cover from very beginning. Okay, so who are beginner to Google Kickstart, they will get highly benefit from this session. Okay, and the expert people will also get some extra information what they have not covered when they solve this problem. Okay, and little bit information about Google Kickstart. Maybe for the people who don't know about Google Kickstart, I will take a minute to tell you, okay, what is Google Kickstart. Google Kickstart is an online competition hosted by Google itself, so that from all around the world different programmers can participate in that, irrespective of their qualification. Either you are BTech, BCA, even you are not studying, you can participate in this event. Every year 8 rounds of this event occurs every year. Already in this year up to A to F already has occurred. Okay, and you can participate in the next round, and if you are scoring good in the Google Kickstart rounds, then you may get a chance of interview call from Google. This all information, actually whatever is written here is provided on their website, on Google Kickstart website. You can go there, you can check out. So this is the chance for those people who even don't get any chance to appear for the Google. If you are dreaming of Google, if you want to prepare for Google, so here is the platform for you to compete. Okay, just prepare yourself with the ingredients which I am asking you to drink those ingredients, and you can participate in this event. And if you will improve yourself, you will work over it, you will definitely get chance to work with the Google. Okay, and what type of problems they ask? They actually ask the problems related to DSA, data structure, algorithm, and competitive programming. Aptitude type of questions remains there actually, and how you will be able to solve those questions. Actually, the more and more you will practice, the more you will be able to solve those type of questions. Before starting, it's better if you pick one language. For one language, okay, I will say, okay, C++ or Java is the most preferable, because they are time efficient as compared to Python, if you compare it with Python. So you can choose that language, and after that you can improve your DSA concepts. After improving that, you can improve your competitive programming, and you can participate in this event. Okay, right now in these sessions, our motive is just to give a taste of this Google Kickstart to you people, so that you can understand that these are not that much tough. You may be thinking that, okay, if the question belong to Google, that may be tough, but that are very easy. They are just aptitude question. You need to have little programming knowledge. Okay, you need to improve your little CP concept and DSA concept, and you can compete over there. Okay, the questions are not that much hard. They are little aptitude type of questions. You can solve them. If you will work, you can solve them. Okay, so here in this session, we are giving just you a taste of these questions. We are solving them so that you can see that, okay, these questions are not that much tough. Okay, you people, any student can actually crack them. Any student, I say any student can crack them. Okay, and one more benefit of appearing this Google Kickstart is you will get free certificate. If you are even participating in one round, you will get the free certificate, and all this information is available on this link which is provided in the description. Okay, let's start with today's session with our problem. First problem of round F. This is the first problem of round F. Name is trash bins. Okay, so let me show you, okay, this same problem on the Google Kickstart web page. I'm going to the Google Kickstart web page. Okay, you can write in the Google, in the search itself, this is round F, Google Kickstart, and if you will click over that first link, you can click, and you will get various rounds here, which next round is G round, and after that H will also occur after that. So 2 rounds are left, G and H only. 6 have already occurred, and we are solving one problem from round F. And let's see, view round F. In this we are solving this trash bin problem. This problem we are solving. Okay, so let me open the problem. This is the problem we are covering today. Google question. So the question: in the city where you live, this is the problem statement, all is written here. Okay, input, output, and some limits and test cases and sample input, sample output. So as usual, I'm not going to read all this statement. I'm going to my PPT. There I just describe this problem in some few lines for you people, so that you can understand the problem, this complete problem, in easy way. Okay, I'm shifting now to my PPT. So the same, whatever problem statement was there, the same is written here. Okay, just describe in more easy way to understand for you people. So what is the problem statement? See, what is the problem statement? So the problem is, let me read these 3 statements. The first one is, there is one particular long street with n houses. With n houses, 1, 2, 3, 4, 5, 6, up to n houses. We have n houses of a street of n houses. That's it. And some of these houses have trash bin in front of them. This house have this trash bin. This is a trash bin. This house has trash bin in front of it. This one is having. This one is having. Some of the house. Some house have the trash bin in front of them. Okay, and after that, okay, what we need to find out? We need to find out what is the sum of the distances that each house owner has to walk to nearest trash bin. So actually every house need to go to some trash bin, nearest trash bin. Okay, nearest trash bin. Every house people need to go to the nearest trash bin to drop their garbage. So they need to find out what is the problem. The problem is, we need to find nearest trash bin for every house, and how many steps that house person need to take to reach to the nearest trash bin, that we need to find out. That's it. What is that? Okay, let me tell you once again. For example, this house, this second house will take 0 step to reach to the destination, to reach to the this dustbin. Okay, this trash bin, because this is just in front of this house number 2, let's suppose. Okay, and this house number 1 need to take 1 step, to reach to the nearest dustbin. This is the nearest dustbin. This one is far away. So everybody is going to the nearest dustbin. So how many steps this third house is taking to reach to the nearest dustbin? Which one is the nearest one? This one or this one? Obviously this one is the nearest one. So minimum steps will be 1. For this house, this is the nearest one. So 1 step. For this house, 0 step, because dustbin is just, a trash bin is just in front of it. This is the nearest for this house, 1. And for this house, you can see, for this house, to reach to this trash bin, this is taking 1-2 step. To reach to this trash bin, this is also taking 1-2 steps. So both are at equal distance. Both trash bins are equal distance from this house actually. Okay, so that can go here or here, anywhere that can go. I am just explaining what is written in the problem statement. Okay, I'm not adding from my side anything. So that can take this dustbin or this dustbin. Okay, so for both of them, that is taking 2 steps to reach to here, to reach to here. This house, the nearest dustbin is this, so 1 step will be taken. For this house, nearest dustbin is this, so 0 step will be taken. For this house, nearest dustbin is this, so 1 step will be taken. And we need to sum all that. You need to sum all that, and that is our answer. And that is required. You need to sum that. That is required. This is the question. Please write Okay, please write +1 if you understand what is the problem. If you have any doubt, you can ask in this problem. Okay, I'm taking little pause. If you are able to understand, okay, what is the problem, please write in the chat +1. Anybody, please write. Please write in the chat if you are able to understand, okay, what is the problem. We have n houses, some trash bins in front of some houses. Need to find out, okay, nearest trash bin to every house. So how many steps every house person need to reach to the trash bin? Those steps you need to find out. Nearest trash bin you need to find out, that's mean. And then sum them, and that is our answer. Okay, so this is the problem. Okay, so this is the problem statement. Okay, let's move on. Let's see the first solution to this problem. Let's see the first solution. So what can be the first solution? I can use the brute force approach actually. By using the brute force approach, see what I can do. For first house, I can see, okay, I can find out. I will move to the left side, I move to the right side, and I will find out the dustbin. Moving to the left, walking to the left side, and then walking to the right side. So I will find out the dustbin from left side and right side, and I will see, okay, which one is near to house 1. Which one will be the near to house 1? So I will count the step up to that. Okay, so for every house I will do the same thing, this same thing. What? For second house also, I will move to the left, I move to the right, and find out, okay, which one is the nearest one, left one dustbin or right one, or maybe third thing can be the dustbin is just in front of it. Okay, for third house also, I am moving to the left, I am moving to the right, and I will say, okay, which dustbin is, then I will compare both the value. Then I will say, okay, which dustbin is, thank you Kaushik, thank you Aryan for replying. Which dustbin is near to the house 3, this one or this one, moving to the left, moving to the right. Okay, so then compare both the value, which one is smaller one, I will write that. For fourth one also, for fifth one also, for sixth one also, very brute force approach. I am using brute force approach. I am checking for every house individually, finding the distance between the house and the nearest trash bin. So how? Just moving left and right for every house. You people please tell me, now this is your turn, please you people tell me, okay, how much time this algorithm will take. If I am using this algorithm, if I am using this solution, how much time this algorithm will take to execute. Please write in the live chat. What I am doing for every house, I am checking left and right. For every house, going left and right, then comparing them, and which one is smaller value, I am putting that value to sum that value. Okay, I am summing all the value then. Okay, for every house I am doing like this, for every house. Okay, you can also tell me that, okay, if we rather than asking the complexity of complete algorithm, if you can find out the complexity of complete algorithm, please write whatever you know. Okay, yeah, whatever you know, please write it. Okay, see, nobody is going to watch you. Okay, this is the right answer, this is the wrong answer. The important thing is you are applying, that's it. Nobody know you here. Okay, nobody know you. I don't know who are you. You don't know who is me. You don't know who is other people here. Okay, simply write that. Okay, why you are changing your life for those people. Okay, please write. Okay, Kaushik is saying order of n, Aryan is saying n square. Okay, let's find out what will be the complexity. Okay, so for one house, let me divide this big problem into smaller problems so that I can find out the complexity. Even you can see how to find out the complexity. Very simple. Whatever steps I have taken, write those steps in English. You write. Okay, and then find out, okay, how many maximum steps you are taking, how many comparison you are doing. That's it. See, first what you are doing. First, what are you doing? For first house, you are checking to the left side, you are checking to the right side. Okay, I'm taking complete brute force approach. Even I know that there is no house at the left hand side. I'm saying, okay, I'm not thinking anything. I'm saying that, okay, I will check. I will follow this step only. I will follow one step only for all the houses. I don't know. I will follow this step only. I'm using very brute force approach. Okay, so first house will check every house to the left hand side, every house at the right hand side. Let's suppose. Okay, maybe he is finding the dustbin at the end. At the end, that may be possible that dustbin is at the end. So in that case, for first house, that need to check out dustbin for at second house, at third house, at this place, at this place, at this place, at this place, all the n places, at all the n places, the first house need to check. First it check for itself also, and then for all of other houses, whether you have dustbin, whether you have. So how many steps that is taking? Order of n. That is, first step, one house is taking order of n. Second house, that is taking for all the houses, for himself, and for left houses, for right houses. So that is checking for all the houses. For second house is also order of n. For third house is also order of n. Fourth house is also order of n. How many houses we have? We have n houses we have. For one house, that is taking order of n. One house is taking order of n. N houses will take n into n. That is order of n square. That's it. This is how we find out the complexity. You don't know, no problem. Now you know. That's it. That's the important point, is that you need to know how to find out. You cannot say that, okay, I don't know, so I will not go through it. Okay. Important point is that now you know how this is coming. That is important. Okay. So please do not worry whatever is your answer. Answer do not matter. Answer will matter only when you will appear for Google KickStart. Okay, even there also, if you are appearing in the starting, no problem at all. What's problem if you are making mistake? Everybody makes mistake. Okay. So the complexity for this algorithm is order of n square. First solution. I'm using very brute force approach. Okay. Let me take another approach. Let me take another solution. Solution 2. Okay. You people tell me, okay, I'm reading all these statement here in English. I'm reading, and you people please listen carefully and try to find out the complexity of this algorithm then. Okay, first let me share the solution for that. Otherwise you people can also think over the solution. What can be the solution? That is important. If you are thinking, that will be developed if only you are thinking. If I am thinking, I have already found out the solution and put all the solution here. I'm just sharing whatever I have already think about that, and I have put the solution here. Important point is that you need to think. That is important. Actually, that is, if you will go for a software engineering job, really software engineering job, means if you are going to the product based companies, there you need to develop the algorithms, there you need to solve the problems. Okay, so again you will get the money for thinking only. Okay, for thinking. If you will not think, then there will be no problem solving. Okay, you need to think. Okay, please, okay, leave this solution. Please try it yourself. Please think, okay, how to solve, how to find out. Question is how to find out the nearest trash bin. How to find out, how a house can find out the nearest trash bin. Just try to generate all the cases that can happen. Please try to find out all the cases that can happen, where you can put the trash bins. Actually, I myself also tried to cover all the test cases by putting the trash bin in this figure. Actually, in figure I tried to cover up all the main cases. You people find out what are the different cases can occur. Okay, try to think to solve this problem. You people tell me, okay, maybe trash bin can be here at first place. Okay, here, but I put it here so that this person can, first person at least, I put it at the second place. See what I was thinking when I was when I was making this problem for you, I was trying to put all the cases. You need to know all the cases. If you are going to solve a problem, you need to think about different cases. And I have put all the cases here only after thinking. I am not writing it blindly. I have already think about it. Okay, so I do not put, you see, I do not put dustbin here, this trash bin here. Why? Because I know that first case may occur. This will be very trivial that okay, I will put trash bin here. Okay, let me put, do not put the trash bin just below the house. First case. Do not put the dustbin just below the trash bin, just below the house. Otherwise you can put there also, you can put there also, you can cover that case also. We need to cover that case also. I cover that case here at second place. But according to I'm telling okay how I think, how I think different cases. If you will think about the cases, then only you will solve the problem. Then you will come with some solution. If you will not think about the cases, all the cases, if you will left one case even, then you definitely will stuck in some test case. There will be some test cases. They will apply the different test cases, and those test cases, some of the test cases, it will fail if you will not able to figure out different cases yourself. You need to figure out different cases yourself. Okay, see, maybe dustbin maybe below below the house, and maybe see the dustbin may be at the right hand side. Okay, so this may be the case, or maybe see for this house, this is the nearest left side is the nearest dustbin. Maybe the dustbin which is at the left hand side, that is the nearest one, or maybe the dustbin which is at the right hand side, that may be the nearest dustbin. Nearest dustbin can be at the right hand side, nearest dustbin can be at the left hand side. Okay, and there may be a possibility that one house is having the dustbin which is left dustbin and right dustbins are at the same positions, means 2 steps from this house, 2 steps from this house. So he can use either this one or this one, but this may be possibility that 2 houses are such like that. Okay, this house will definitely put at the left hand side, and this house will definitely put at the right hand side. Okay, but here I put 3 houses so that I can show you that okay, there is one common house which can go to the left also, which can go to the right also. Okay, and one more you can think over that. Okay, see, this is the last house. Where the last house will go? Last house, actually, even you can think last house do not need to go at the right hand side. Okay, so he will either find dustbin here or here. Okay, so I put it here. So I just try to figure out different cases where maximum I try to find out different cases so that I can solve it. Okay, so if you need to find out the different cases, you need to figure out the different cases. Okay, and definitely they will come slowly in your mind. Definitely you will be able to solve the problem. Okay, let's see the second solution. What will be the second solution? Let me rub the board first. So let's see the second solution. Very easy. See, very easy solution. That is also in the first case. In the first solution, I was checking left and right for every house. For every house I was going left, right. For second house I was going left and right. For third also I was going left and right. Rather than like doing like this, can I do something like that? Okay, I scan all the house in one go, and while scanning all the houses, if they have trash bin or not, can I find out their left and right in one go? Can I tell okay, when I am going from here to here, I find a dustbin. I find a trash bin or dustbin. I am using 2 words for this. So I find a trash bin. Now I am moving from here to here. Now you can think okay, definitely this will be the nearest dustbin for all the houses which are at this side. For all the houses which are at this side, because this is the first dustbin, so all the houses which are at this side, they will be, for them, this will be the first dustbin. Okay, let me move on. If I am moving more upward, I come to this house. For this house now, I need to compare. See, for this house, I cannot, for this house, I cannot directly say that, okay, this is the nearest dustbin. Because maybe dustbin is also available here at this position. Okay, or maybe dustbin at the right hand side, just here. Okay, so I need to check for this. When I am moving more further, after finding first dustbin, for second dustbin when I am going to find second dustbin, for all the houses which I find out in between first dustbin and second dustbin, I need to compare their left and right. I need to compare. Then only I can tell, okay, which one is the nearest to this house. I cannot directly say this dustbin will be the near to this, because maybe one dustbin is here. So I need to compare the dustbin which is at the left and which is at the right. Okay. And if the dustbin at the same position, that is the nearest one. If that is the dustbin at the front of the house, that is the nearest dustbin. And moving on, I'm moving on for the third dustbin. For third dustbin also, see, important point. I'm applying the same logic which I apply here. For all these houses which are between second and third dustbin, I'm applying the same logic. What? I need to compare left and right. I need to compare left and right. For last one, you can little bit optimize. Even I don't know if this is the last one or not. For this one, okay, if this is the last one, you find out this dustbin, this is the third dustbin. After that, you see, okay, there is no dustbin after that. So you can say that, okay, because there is no dustbin after that, can you say that? Okay, there is no dustbin after that. So all the houses here, any house, any number of house, for all the houses, this will be the nearest dustbin. Similarly, over all the houses here, this will be the nearest dustbin. Here, all the houses, because this is the first dustbin, this is the last dustbin. So all the houses, this will be the nearest dustbin. Okay, and for these, we need to compare left and right. Okay, so this can be one approach. You can use your own different approach. Okay, let me take another one. Approach. Erase all. I'm saying, okay, let's keep it little bit more simple. Okay, when we are going to reduce the complexity, Okay, what was the complexity in that case? Actually, I will ask about that. Let me take little bit different approach. I will take only one step. And complexity will be reduced. These are solutions I have already think about. I'm not I think about this problem, I'm sharing different solutions with you. Okay, so you need to think about that. You need to think yourself. Okay, and how you will think at the moment, that will come with the practice. The more and more you will practice of DSA and CP and these type of questions you will go through, the more you will get, the more fast you can solve this problem. Okay, so if I will say that after taking this class only you will be able to crack the Google KickStart, no, you will not be able to crack the Google KickStart. You need to you need to clear side by side. You need to clear your CP concept, you need to clear DSA concept, you need to be good in one language. C++ or Java maybe is the good one, I think, for competitive programming type, this type of questions. Okay, so I will not give you false hope that, okay, only by taking this series you will be able to crack. Yes, this series will set in your mind that, okay, this is not tough. These problems are not tough. This is set in our mind that, okay, these are Google problem, this will be tough. People will always say that, okay, these will be tough. And if you will think again and again over that, these will be tough, that will become tough. These are not tough, these are very easy. I am sharing many solutions. You need to find out one solution only there. Okay, so another solution. Let me take another solution. You can simply say that, okay, for every house, while I am going from, see what I can do, what I can do. And moving from left to right. I'm moving from left to right. Okay, while moving from left to right, from here to here, let's suppose I'm finding, okay, left. left dustbin. See what I'm doing, and let me write here. Find left dustbin, or they are using trash bin word. Trash bin for find left trash bin for every house in, let me write here or here, in one go. One go means I'm going through all the n houses one time. Okay, so I'm after, if I go all through n houses, I will be able to tell which is the left dustbin of every house. I'm taking third solution. Okay, so can you tell is there any left dustbin to this? There is no left. Okay, you can put, okay, maybe you can put infinite here, any value. You can saying that okay, there is no dustbin at the left hand side. You start from here. You see, okay, there was no dustbin, or okay, so you put infinite value here. You reach to this house, so you find out that okay, dustbin is at 0th position, at 0th distance from this house. You reach at this house. You are talking about left dustbin, left trash bin. So left trash bin, you are saying okay, that was at first position, so the distance is 1. You can calculate distance in constant time. Okay, so for this house is left. I'm talking about left trash bin only left trash bin. So because we know the last left trash bin position, so I can calculate okay, the distance will be 2. Talking about left trash bin. Okay, what about this? The trash bin is here itself, so this will be 0. What about this house? This is done. This house, the nearest left trash bin is at 1 distance away. The nearest left trash bin, because I have gone through the left trash bin. I don't know about the right trash bin, but I gone through the left trash bin while moving from here to here in one loop actually, which is going through n houses. So the left trash bin is at 2 distance away. Left trash bin is at the 3 distance away. So here the trash bin is at the same position, so position is 0. Left trash bin is at the one position away. So I find out the left trash bin in one go. What? Second step, find right trash bin for every house in one go. Now find right trash bin. Another loop, one loop gone. Okay, from 1 to n, one loop gone, and I find out this value, left trash bin for every house. Now I am finding right trash bin for every house. This was the left, this is the right. So for right one, okay, you can start for right one, you can start from here. You can start from n, you can come to 1. You can reverse the loop. You can second loop. So you are starting from here. Is there any right side? Is there any trash bin? No, I don't know. So infinite. For this house, okay, for this house, actually the trash bin is at the same position. Okay, and for this house, this one, okay, this one, the right trash bin. Now I know because I am moving the loop from here to here, here to here. So I know about this trash bin. Forget about this line now. Forget about first step now. This is another loop. This is different loop. So now for this, I know trash bin at the same position. For this house, trash bin at the right. I have gone through this trash bin because I am moving from right to left. So I know the position of this trash bin. This is one step far away. I can calculate it in constant time. And for this house, right trash bin is two steps far away. For this house, right trash bin is 1, 2, 3 steps far away. For this house, right, okay, the trash bin is here itself, so this will be 0. For this house, right nearest trash bin is 1 step far away. For this step, right one trash bin is nearest is 2 steps far away. For this house, that is on 0. For this house, right trash bin is 1 step far away. So I perform 2 steps. After that, simple, take minimum of left and right. Take whatever you have calculated this value by rotating 2 loops of order of n. Now you can find out minimum of them. Okay, which one is minimum of out of these two, infinity and 1? Let me write minimum here. So minimum here is 1 out of these two. Which one is minimum? 0. 0 is minimum. Which one is minimum? 1. Which one is minimum? 1. Which one is minimum? 0. Which one is minimum? 1. Which one is minimum? 2. You can see both the left and right were at the 2 steps far away. Which one is minimum? 1. Which one is minimum? 0. Which one is minimum? 1. Now you can add all of them. This. You add all these values. Let me write 4th step. Sum all the value, all the minimum value what you have got. Okay, this, and that's the solution. Now this is your turn. Please, you people tell me for this solution, third solution, this solution, what will be the time complexity? Please, you people tell me. Please, you think over it. That is important part actually. You need to think over it. You need to write. You need to give whatever you know, whatever you find out. Please write. Okay, other people also. So that is, let's find out. For first step, what is the complexity? This is one loop. One loop I am rotating. Okay, one loop I am rotating. So I find out all these values for this, all these values. So what is the time complexity for this? Order of n. Okay, see this loop, the loop of second for right one, this loop is not inside this loop. I am calculating left trash bins, that is one separate loop. I am calculating right trash bins, that is separate loop, that is not inside that loop. Okay, that is one is, this loop is separate one, this loop is separate one. I am performing two different tasks. So this loop will also take order of n time. Okay, after that, okay, even though you can perform these two operations inside this loop itself, but if let's suppose I'm taking a different loop for that also. Finding minimum will again take order of n time. This is separate task. After that, summing will take, okay, if you will take, okay, again you take you use very simple method. You add all the value one by one by getting those value. Even that will take order of n time. Even you can reduce that time. You never need to put this. You can use this loop itself. Okay, let's keep it simple. So these steps take order of n time. These steps take order of n time. These steps take order of n time, and this step, all the steps, important part is all the steps are working separately. They are not inside each other. Okay, so the complexity will be find out like this: order of n plus order of n plus order of n plus order of n. So this is how much? Order of n. So this is where you need to know about DSA. In DSA you will learn how to find out the complexity. So if one code is inside other, then you multiplied the nn. But if two codes are separately written, then each complexity and this complexity will be add up. That will not multiply. Where you will learn this concept? You will learn this concept in DSA. That's why I ask you to drink the cocktail. In cocktail you are drinking, okay, language C++ maybe or Java, and then you are learning about DSA. You are knowing about the complexity. You are knowing about different algorithms, different approaches to solve the problem in DSA. After that, competitive programming. Okay, in competitive programming, you are understanding a little more about more advanced data structures, and then applying them to solve some aptitude type of problems. Okay, there you will learn that skill, and these problems will solving previous quick start problems will give you kick to go for the Google. Okay, so that's why that cocktail is important. So the complexity for this algorithm is order of n. No problem at all. No problem at all. Okay, so this is the code for the solution. Trash bin solution. This is the code. Whatever I have explained, that is same thing is written in the form of code. There is nothing new here. You can check out. Okay, you can check out. So let's in the actually in the question they provide the input in the form of string. They are saying, okay, these are, we have, how many houses we have? We have 10 houses, 0 to 9. We have 10 houses, 0 to 9. Okay, and wherever is in, we will input this string. We will input this string actually. We need to input a string in the form of 0, 1. We can take the input string in the form of 0, 1, and wherever is written 1, that is showing what? Means there is a trash bin. There is a trash bin in front of this house, house number 1. There is a trash bin in the front of house number 4. There is a trash bin in the front of house number 8. So input will be string of 0, 1. 1 is showing, okay, there is a trash bin at this position, and index is showing the number of the house. Okay, this is the input. Simply a string. You have taken the input of 0, 1. 1 is showing that is a trash bin. Okay, and same approach, solution 3 I have applied to solve the problem. So we I'm saying, okay, long, this long, and this is showing the last element. I'm considering that, okay, this is actually minus 1 into 10 power 9. I'm considering this value as infinite actually. Okay, even I will say, okay, minus infinite. You can say that, okay, you can, okay, that is infinite, you can say, okay, for the left hand side. So that's why this put minus. I take large value, keep it simple. Okay, and I use a vector of long. Okay, the name is, object is answer, and there are n elements in that, and the value of every element is this. So this is 1 into 10 power 9. Who don't know what is 1e9? Okay, and I execute one loop here, simple, one loop here. This is for calculating actually left of I. This is for calculating right of I. You know this thing. We have already done. We applied 2 loop to calculate left and right, and then I sum whatever answer I get. I sum them. Okay, so you can apply it here also. So this loop will, see, you can see this loop will go from 0 to n minus 1, because I am starting from 0. So maybe, so n value is 10 here in this case. So this will go up to 9. So 0 to 9. First loop will go from here to here. This is what we have done in previous slide to calculate left dustbin. So loop is going from 0 to n. And in the case of finding right dustbin, I was moving from right to left. So n minus 1 to 0, n minus 1 to 0. So this loop is moving from back side to front side, from n minus 1 to 0, to find out the right right dustbin from every house. Okay, and after that, if I find any string value 1, okay, so that means dustbin is present at that place. Okay, and what I am doing here is that, see what we are doing. Let's apply one value in this code, and then try to understand. Okay, but one thing is clear. This code is for finding the left dustbin. This code is for finding the right dustbin, and then we are summing them. Whatever answer we are getting, we are summing them. Overall is clear. And this loop is going from left to right to find out the left dustbin for every house. This loop is going from right to left, n minus 1 to 0, to find the right dustbin. Okay, so let's execute this part. We can understand this part easily if we put some value from here to here. Okay, one value is enough actually. Okay, so let's suppose you can take any house, and you can find out the value. Okay, let's start with this value, first house, 0th house also itself. For 0th house, even if I ask you people, please tell me, for 0 house, this I value is 0 in the starting, first time I am executing this loop, I value is 0. Okay, and last value is infinite, minus infinite. You can say, okay, minus infinite. That is some large value minus large value. I am saying, okay, minus infinite. Okay, and this is a minimum function that will find out the minimum out of this or this value. okay, and that value will be stored at this answer position. This is actually answer. This is storing as a answer. This is the answer you will get here. Okay, you know the value of I, that is 0. You know the value of last, that is some large value actually, which you can take, okay, infinite, minus infinite. Okay, last is minus infinite, otherwise that is some large value. For simplicity you can say minus infinite, and min is the minimum function which will find out minimum out of this and this. Now you people tell me, please you people tell me what value will come here at this position. Please you people tell me what value will come here. You need to do it yourself. Anybody, please tell me what value will come here. Means what value will store at this position. What will be the value here? Can you calculate? You know the value of I. First time I am executing loop, I value is 0, last value is minus infinite, and minimum is the function to find out minimum out of this and this. So what will be the value you will get here? You need to execute these two codes. Please try it yourself. Give me one value, then we will move on. Chirag, very good. That is infinite. Very good. Even you will say more correct, that is Aryan minus infinite. Okay, so that is infinite. Very good. Thank you for sharing. This will keep me also motivated, okay, to interact with you, and I can put more energy only when if your response is coming from your side. Okay, if I will not get the response from your side, then my energy automatically will go down actually. Okay, you people are doing good. Please help me to fill all these metrics. Execute the loop again. Please execute the I value is 1 now. I value is 1. Okay, and please tell me what value will come here. Please, you people help me now. I am going to be lazy now for some time. Please help me to fill these values, to execute this code. You are rotating this loop. Please help me. Second value, this for first house. Anybody, please help me. Okay, you have done it, Aryan. So that is infinite 0, 2, oh sorry, you have written 1 here, that is 2, 0, 1, 2, 3, 0, 1. Okay, so how you are finding actually, see, you can see here, if you will execute this code, one thing is clear, you are finding the position of left dustbin. See, the left dustbin is one step away from house 2. Left dustbin, this is the dustbin, this is the trash bin, one is the trash bin, is 2 steps away from this. Left trash bin we are searching. And what about this? This is trash bin is just below it, so that will be 0. For this one, because trash bin was here, so 1 step is away. For house number 5, trash bin is here, so left trash bin is here, 1 step away, 2 step away, 3 step away, trash bin is here itself, 1 step away. Very good. Similarly, you need to find the right trash bins by executing this code. So whoever accept Aryan, Kaushik, very good. You also find out the solution. Accept Aryan now. Aryan, you understand the concept. Please, you do not give the answer now. Anybody? Then Aryan, please let me know what value will come here. Here, not here, actually here. This is starting from the end, so we will move from here to here. Okay, from n minus 1 to 0 we will move on. Okay, and actually one more thing, we are not using li and ri. What we are using? We are using this name, answer. Let me write here. We are using ns, answer of I. Okay, we are storing all the values here, and you need to find out the value here. Okay, Aryan, there is a little trick here, so you can also try. There is a little trick here in this code. let me see if you can also find out this or not. So what you people need to be done is you need to tell me the value here by executing this code. Keep in mind now you have the value of a answer I as this value. You have calculated, you have executed this code, so you have this value with you. You have this value with you in this vector. Okay, so you are going to use it actually here. That's why I am telling you. You will compare, you will pick the value from here when you are picking the value for a and for this vector. Okay. Okay. So anybody can tell. Start from here for this what will be the value for ninth position. For ninth position, this is I value is 9 here, and let me try myself. You people can try yourself. And so last I will say, okay, last variable is having infinite, positive infinite. There is no minus here. Some large value I am taking actually as infinite, and there is nothing infinite. That's why we need to take some value. And is 1 is at SI, that is 1? No, that is 0 at SI. This is SI. Is 1? No, that is 0. So this condition fails. And so what is the value at answer of I, answer of 9? That is 1. So value here is 1. And what is value here? Last is infinite minus I actually doesn't matter if we have infinite with us, so that will be infinite. So from here I get infinite, from here I get what value? I get this 1 actually. Okay, so this 1. So which one is minimum? 1 infinite, 1 is minimum. So what I am storing here? So Kaushik have done it. So actually what value will come here? What value will come here? Is that infinite will come here? I am getting 1. I am getting 1 here. But Kaushik, you are getting infinite. So what's the problem? How 1 can come here? According this code, I am applying this code now. I am saying that okay, this code is actually is not only finding out the right dustbin, also this is finding out, this is also doing one more job in this, that is comparing left and right also. See, there were 4 steps in previous, I have tell you, find left dustbins, find right one, and then which one is minimum, from left and right. Here we are finding minimum here itself. Rather than finding left and right only, we are finding minimum also. So here out of 1 and whatever you get, Kaushik, whatever you get, that is infinite. So 1 and infinite, which one is minimum? 1 is minimum. So final answer we are putting according to this code. Final answer we are putting. Okay. So otherwise, what you have written, let me copy your values. So you have written infinite and 0 2. Let me correct if I am making some writing mistake. 0 3 2 1 0 1. So you are finding right. Okay, you are finding right dustbin, distance from right dustbin. Let me check if that is right or not. So distance from this the right dustbin will be at position, will be 2 steps far away. So this will not be 1, this will be 2, and this will be 1. This will be this is this, this is this, this is this, this is this, and this is 0, and maybe that is shifted this side one, and this will be 1 2 3 3, and this will be 2, this will be 1, this will be 0, this will be infinite. So these are the position of the right dustbin, okay, and I need to compare which one is minimum. 1 and infinite 1, 0 and 0 0, 3 and 1 1 actually, 2 and 2 2 actually, say both are same, okay, and 1 and 3 1 actually, 0 and 0 0 actually, 2 and 1 1 actually, 1 and 2 1 actually, 0 and 0 0 actually, 1 and infinite and minus infinite 1 actually. So this is actually, this code is also comparing this value with this value, okay. This is doing both the job together in a, rather than writing a separate loop again for finding minimum. Here we are finding minimum here itself, and after that we are summing. On vectors we can directly perform the sum operation. In array you need to add up all of them one by one, but in vector there is a function of sum. So that's why you need, if you are not aware of vectors, you need to go through C++, this C++ code. So that's why I was asking you to drink the cocktail. If you are not aware about vectors, there you need C++. Want to know about the complexity, you need to DSA and different algorithms. If you want to know about little bit these type of problems you want to solve, then you need to go through the competitive programming, okay. So you need to go through all of them. So this is how this code is working. Otherwise you can go it once again from your side. After that you can sum up all of these and you will get the solution, okay. This is how this code is working. You must be getting some idea, okay, how this code is working. If still there is any doubt, you can check out it later. You can check out this video later and check out, okay, how this code is working. Let me clear once this board for you people so that you can see the clear code here, okay, and this is the input, okay, for your later practice, okay. That's it for this session, and best of luck for next Google Kickstart round. Whoever is appearing for that, I will suggest everybody please appear for that. You will get some confidence from there. Solve one problem only, okay, first problem only, or 2 problem or 3 problem. Try them. See, whenever you are going for some exam, it's better you keep preparing for that. Keep preparing for and C++, STL you can prepare, and you can prepare for DSA, you can prepare for competitive programming. With that, in parallel, it's better you go for the Google Kickstart. That will keep you motivated, and that will keep you updated, and that will you will realize that, okay, you need all that stuff. Important point is that is the only way you have. If Google is not coming in your college, you don't have any other way to go there. And if you will devote your 6 months, I will say 6 months are enough to cover all that stuff, language, C++, DSA and CP. 6 months are enough to get a kickstart, okay, and more 6 months plus more 6 months, you will be good at that, okay. More 6 months, 1.5 year, you will be able to crack and you may get place in Google, okay. So if you will start preparing right now, after 1.5 year, even if you are in 4th year, even you are pass out, even after going to pass out after 5 years of your BTech, if you are in Google, you are at good place, okay, and you can do that in 1.5 year, even less than that if you are giving more time to that, okay. If you want to go for one more information, if you want to go for competitive programming course, if you want to take that, GeeksforGeeks is providing that. All information is provided in the description. That is given by Joseph Amritraj, who is the Grandmaster. Okay, you can get all the information below in the description or on our website. Okay, best of luck for your future. Keep learning, keep preparing. Do not leave these things in between. Just keep moving on. Okay, just keep moving on. Okay, I'm ending this session now. Thank you so much. Thank you.